In this video, we're going to talk about limits involving infinity. So first, we want to talk about horizontal asymptote. So as limit of f of x, as x approaches infinity, it means that x is approaching a big number, such as million, billion, trillion. And when you have a limit b, which is a real number, or as x approaches negative infinity, and it approaches a real number, then y equals b is a horizontal asymptote. Let's look at an example. We have f of x equals x over radical x squared plus 1. So let's see what happens as we approach infinity. But let's see what happens to y value. So let's graph this and see what happens. So I'm going to graph, and I got a nice graph because I set my window as this screen right here. And notice my y-scale I set it at 0.5. So when you graph this is 0.5, that's 1, that's 1.5, and so forth. That's how I set it up. So let's press trace. As x gets bigger and bigger, what is the y value that you're approaching? It looks like you're approaching 1. What about what happens as x gets smaller and smaller? As x gets smaller and smaller, it looks like you're approaching negative 1. We could double check that by using table. So let's go to press second, graph for table. Let's go to, let's see, clear. Let's plug in, let's say 100. Press enter. And you get 1. What about 1,000? You get 1. What about 1 million? So as you can see, as x approaches infinity, y value is approaching 1. What about negative infinity? Let's put negative 10. You get negative 0.995. What about negative 1,000? You get negative 1. What about negative 1 million? You get negative 1. So as you can see from the table as well, as x approaches infinity, limit is approaching 1. And as x approaches negative infinity, limit is approaching negative 1. So we could say that this is 1, and that's negative 1. So that means we have two horizontal asymptotes, which is y equals 1 and y equals negative 1. Now let's talk about vertical asymptotes. Line x equals a, where a is a real number, is a vertical asymptote when this happens. Limit of f of x as x approaches a from the right side. If it goes to positive or negative infinity, or as you approach a from the left, and if the limit goes to positive, negative infinity, then x equals a is a vertical asymptote. So let's look at some examples. So when you have f of x equals 1 over x squared, you know that from pre-calculus, vertical asymptote most likely happen when the denominator is 0. So when does this denominator goes to 0? When x equals 0. When x equals 0, denominator is 0. So let's look at the graph of 1 over x squared. So let's use our graphing calculator to graph 1 over x squared. I'm going to graph it. As you can see, when x equals 0, it's a vertical line. X equals 0 is a vertical line. As you approach 0 from the left, what happens? It goes to infinity. What about when you approach 0 from the right? It goes to positive infinity as well. So therefore, we have limit of 1 over x squared as x approaches 0. It went to positive infinity, and we have limit x, from the left side, and we approach x, as x approaches 0 from the right, we went to positive infinity. Therefore, x equals 0 is a vertical asymptote. What about f of x equals 1 over x minus 1? You know that when x equals 1, this function is undefined, so most likely x equals 1 will be a vertical asymptote. So let's check what happens as we approach 1 from left and from right. So we have 1 over x minus 1. So let's graph that. So here's x equals 1. Now notice what happens as you approach 1 from the left. You go to negative infinity. What happens as you approach 1 from the right? It goes positive infinity. Remember, there is a vertical asymptote, whether it goes to negative infinity or positive infinity. So, since we have limit of f of x, as x approaches 1 from the left, and you went to negative infinity, and limit as x approaches 1 from the right, went to positive infinity, x equals 1 is indeed a vertical asymptote. So as you can see, to find the horizontal and vertical asymptote, you have to rely on graphing calculators.